Michelle. Yeah, so yes, this is being recorded. So we'll be happy to share with all of you a copy of the recording afterwards. My name is Heather Fennick. I'm with the Lower Raritan Watershed Partnership, and this is our first Lunch and Learn of 2023. And we have a great group of folks with us today. We have our Rutgers Cooperative Extension of Middlesex County partners, Michelle Backus. We have the LRWP's Water Quality Monitoring Outreach Coordinator, Jocelyn Palomino. We have Samantha Wilder with the Interstate Environmental Commission. The IEC is the lab that processes our samples pretty much in real time for us so that we can deliver pathogens data to our larger watershed community on Fridays after we've done our monitoring on Thursdays. And we also have a Rutgers student, Victor Aguilar, with us, who's going to speak a little bit about some of the work he's been doing to better understand how we can improve our monitoring. He's been doing analysis of a survey that we've deployed. So we welcome you all to our info sharing session today. I just want to orient you a little bit to our Zoom. We have at the bottom of the Zoom a couple of ways you can interact with us. There's a chat feature that is open for all of you. If you have questions, please enter those into the chat. We have also on the bottom tray, you can show captions. So feel free to use that if you want caption settings disabled or enabled. And then, we're always happy to see happy smiley faces or thumbs up or thumbs down or question marks. If you want to annotate along with us, there is a reactions tab at the bottom of the queue as well. So again, welcome. I am going to open up I'm going to do a screen share and open up our presentation and we'll get started. So just bear with me here. So we'll be talking today about Raritan River data, specifically pathogens data that is collected by the Lower Raritan Watershed Partnership and several other partners, especially our Rutgers Cooperative Extension of Middlesex County partners. So we'll be providing an overview of the project. We'll talk about some of the data results from the last few years, 2019 to 2022. We'll talk about why this is important, making the link between water quality, pathogens, and stormwater. And there was a question already in the chat asking about the link between land use and flooding and pointing in the direction of links also to water quality. And we may address some water quantity issues as well. We'll talk about how you can get involved. And then we want some input from you in terms of our water quality data sharing and how we can improve the outreach of the information that we gather throughout the summer season and see how we can better disseminate this information. Okay, so our program is organized during the summer months. Those are the warm periods of time when you're most likely to see people out on the water, canoeing, kayaking, fishing, jet skiing, allowing their dogs to run in the water, in some cases swimming. And we monitor at 6 different non-bathing public access beach sites along the tidal portion of the Raritan River. So these are locations that are accessible, easily accessible, are public park spaces that are officially sanctioned for water quality monitoring. And we want to know, to what extent do the waters pose potential risk to folks in terms of disease-causing pathogens? We want to know, is there a potential for contact with the waters to give us skin infections or in some way make us sick? So pathogens are disease-causing bacteria that are often caused by fecal waste. So what we're testing for are two things. We're testing for the amount of fecal waste and also for the amount of a specific type of pathogen called Enterococcus in the waters. So we have a poll here for you. Let's open up that poll. Michelle, can you run that, or do you want me to open it up?
I believe I can. Yes. Heather, also, if you wanted to make your screen full screen in presentation mode, but I'll go ahead and launch the poll.
Okay, here we go.
Can folk give me a thumbs up if everybody can see the poll? And all right, thank you, John. I see John's saying yes.
Yes, you were aware. That's great. Okay, we're getting a lot of yeses. I think that's probably everyone's answered. Okay, so we'll close this poll.
I'm going to share the results.
Awesome.
So there you can see about 70% of the people said yes, and 30% folks said no. All right.
Okay, great.
Okay.
So I'll move forward here. So I'm going to need to stop sharing and then get back in here with apologies. Can you all see my screen again? I think the poll,
we did, and then it went away.
Yeah, I think the poll froze the screen. So hold on just a second.
It's visible now.
Now we
It's
see
visible. I'm not able to advance it, unfortunately. Michelle, can you get in there by chance? And share your screen and
sure. Yeah.
Yep. Sorry, it froze mine.
All right.
Great.
So we were, I think, here.
Yeah. Okay. We can move to the next slide. Thanks, Michelle. Okay, so we collect the data with a couple of different, using a couple of different tools and a couple of different approaches. So the most basic is the actual capturing of a water quality sample, sort of a water sample that's then analyzed by the lab. So we also, when we go out to each of our sites, fill out an intake form of information about what we observe in the landscape. We call that our visual habitat assessment intake sheet. So we're looking to see if there's visible signs of trash, of dog waste, of the presence of birds. And we use also a tool, you see this in the bottom right-hand corner. It's a tool called a YSI that will drop into the water. Has a series of probes installed in the device that provide information on our water temperature, how salty or how much salinity we're getting in the water. This is a tidal waterway, so salinity can be related to our tidal conditions. And this is an estuarine waterway. It can also be related to salt on roads in winters. We have our dissolved oxygen, we have conductivity, pH, and this device also tells us where we are in space, our latitude and longitude. Okay, we can move forward. So Jocelyn, do you want to talk about how we run our water quality monitoring on our Thursdays?
Yeah, of course. So hi everyone, I'm Jocelyn. I'm the outreach coordinator for the water quality monitoring program over the summer. I am also a Rutgers student majoring in EPIB, which is environmental policy, institutions, and behavior, and also minoring in public health. And I've also been helping the LRWP with their data management and Spanish outreach. So here's a quick glimpse of what a day of water monitoring often looks like. So as you heard before, our season runs from May to October, and we sample on Thursday mornings, starting in Piscataway down to Perth Amboy. We usually meet around 8 a.m. at our first site to do any pre-calibration of the YSI, which is one of the instruments that we use. And then we begin collecting our samples around 8:15. And afterwards, we drive or carpool to the other sites. And with our team of volunteers, we work together to collect samples, record data, any observations, and assistance with the YSI. So we typically finish by 11:30 in 2nd Street Park in Perth Amboy, and we then hand off the samples to someone from the Interstate Environmental Commission. So this is just a quick snapshot of what our Thursdays in the summers looks like. And it's always a great time with our volunteers out in the field. So you don't have to commit every Thursday, but if you are interested in joining us over the summer, please be sure to register for our training, which is May 18th at the Earth Center near Davidson Mill Pond, and our monitoring season begins May 25th.
Excellent. All right. Heather, can you see that slide?
I can, yep.
Did
So
you want me to take it from here?
Yep, sure.
Okay.
If you want to jump through, yep.
Sure. Hi, everybody. I'm Michelle Backus with Rutgers Cooperative Extension in Middlesex County. I'm sitting in Middlesex County, wearing a Rutgers shirt, sitting in Middlesex County because I'm part of Cooperative Extension. We're the outreach arm of the university, and we've been partnering with the Lower Raritan Watershed Partnership on this project since we started in 2019. So I'm just going to tell you a little bit more about Enterococci and some of the variables that we sample for and some of the results. So what we look for in our river water samples, we're looking for, we're sampling for fecal coliform and also Enterococci. So if you're thinking that that sounds a lot like poop, it's because it is. Essentially what we're looking for is pathogens in the waterway. So when we take our water samples, what we're looking for is an indicator that there might be pathogens in the waterway. Okay, so what is specifically Enterococci? You can see some pictures here. There's a picture of Enterococci on the upper right. It's a spherical shaped bacteria that's found in the guts and of warm-blooded mammals. And then it's excreted in feces. So Enterococci in itself is not harmful, but it's an indicator that there might be other pathogens in the waterway that could make us sick. So what I mean by sick, it means that we could have, if we're exposed to the water, we could have gastrointestinal issues. If we have a cut on our skin and get in the water, if there are pathogens in the waterway, then that cut may get infected. Some people may have problems with UTIs. So this is why we're sampling for pathogens, because we're concerned about human health. And the sampling that we are doing is the exact same sampling that goes on down at the bathing beaches on the Jersey Shore every day. This is also what they're sampling for. They're sampling for Enterococci. But because we don't have bathing beaches on the Lower Raritan, that sampling is not being done, but people are still using the river. So we are doing this sampling to make sure that we can tell people about how healthy the water is and how safe the river is to use. So Enterococci is the indicator that's used for marine waters. E. coli is used for freshwater streams and rivers, but in marine waterways, which the Lower Raritan is, it's brackish water, brackish and marine water. That's the indicator that's used, Enterococci. And then there's a standard that we look for. The Department of Environmental Protection, the state sets a standard for different pollutants in the waterway. And it's actually set by the EPA, the federal government. So for what's called primary contact recreation, that's swimming and fishing, the standard, what we look for is to see whether or not the levels are above or below 104, what's CFU, which stands for colony forming units. Or there's another way to look at it, the geometric mean. Within a 30-day period, is the geometric mean more than 35 colony forming units? So that's the standard that's been set. And when we look at the results, we can look at it based on the standard. So this is how you may have seen the findings. If you have seen the results, this is the way you may have seen it. Comes out with the table, and there's also a map, and there's happy faces and frowny faces that indicate whether or not the water is above the standard, above the water quality standards. It's a frowny face, and then if it's below the water quality standard, there is a happy face. So you may have seen this. So there is a second poll, which I think I can start it from here. Oh, you started it. Great. So if folks go ahead and take that second poll, and this one is different from that first question. It's first one was, were you aware of the monitoring? This one as, now that you've seen what the data looks like, is it jogging your memory? Have you seen the monitoring and data results? Okay, a little bit different answers now that folks have seen it. Some folks are saying, wait, this may look familiar. All right, I think most people have answered the poll, so I'm going to end the poll and share those results. And you can see that 55% of folks say yes, 40% say no, and one person said, I'm not sure. All right, so let me get rid of this. And hopefully, all right. So this is the way you may have also seen it this way. You may have seen the map that Jocelyn sends out this data every Friday. So the water quality results come out. We sample on Thursday, as was mentioned, and then the results come out on Friday. And that's so that people can make their decisions about their weekend recreation activities. So maybe someone was interested in going fishing. Maybe somebody was interested in going paddle boarding. They can look at these results and say, okay, how safe is the river to use? What were the water quality results? So there is a third poll question that Heather is going to do. And this is, how have you used the water quality data? So for those folks that have seen the data, how have you used it? Maybe you haven't used it. You can tell us that too. So we'll just wait for some folks to answer. All right, so looks like most folks, I think, have answered. I'll give it 5 more seconds. All right, and then I'm going to end the poll, share the results. So a couple of people have used the data to inform their water activities. A bunch of folks are saying that they have not used the data, and a few are not sure. All right. Okay, so now let's take a look at the results. So we have a couple of different results slides to show you. I'm going to show you the results from all of our years of sampling, and then we'll take a closer look at 2022. Okay, so these results here are from all the years of sampling. Okay, and this chart here shows each of our sites. So here's Riverside Park in Piscataway, that's our first site. Here's Rutgers Boathouse in New Brunswick. The third is Edison, then there's Sayreville, then there's South Amboy and 2nd Street Park. And what this second column here shows is the percent exceedances of the water quality standard for Enterococci, okay? So how many times we've taken at each of our sites across all the years that we've been sampling since 2019, we have taken 69 samples per site, okay? So the results are at Riverside Park, 84% of those 69 samples have come up above the water quality standard. At Rutgers Boathouse in New Brunswick, 66% of the samples have been above the standard. Edison Boat Basin is also in the same range there at 67%. And then in Sayreville, Ken Buchanan Park, half of the samples have been above the water quality standard. At South Amboy Waterfront Park, 23% of the samples have been above the standard. And then at 2nd Street Park in Perth Amboy, 45% of the samples have been above the water quality standard. So kind of our worst site for pathogens is in Riverside Park in Piscataway. And then the one that's you could call our best site is South Amboy Waterfront Park. And again, the standard for Enterococci is 104 colony forming units for a single sample. Okay, and then here's some of the other variables we look at. Heather mentioned some of them before. We're also looking at the precipitation. So we look at what's called 2-day antecedent precipitation. So how much rain we've gotten 2 days before our sampling event. We are also taking the air and water temperature. We're looking at those parameters. We're looking at the salinity of the water. Okay, so the salinity and conductivity are related. So salinity is a measure of salt in the water. Ocean water is about 35 parts per thousand. That's for full-on marine water, ocean water. And then our waters are mostly brackish water, meaning that they're a mix of fresh and saline water. So like the Riverside Park site, all the way upstream has a large freshwater source. So we're usually seeing it at like 0.1 parts per thousand. And then by the time we get all the way down to Perth Amboy and South Amboy, that salinity has increased because it's more marine. We're also looking at conductivity, which is a measure of how the water's ability to conduct electricity and how much dissolved salts are in the water. It's also an indicator of if we see an increase in conductivity, it means that there might be an increase in pollutants in the water. We're looking at the acidity of the water. We're looking at dissolved oxygen, which is very, very important. Aquatic organisms need dissolved oxygen in order to thrive. We're looking at the tides, and we're also looking at barometric pressure. And what we're doing when we analyze the data is we're looking to see if there's relationships between these parameters over here on the right and our Enterococcus. We're looking to see, are they correlated in any way? All right, so this slide here is just our 2022 results. Okay, I know it's a little bit different. We're throwing a lot of data at you, but that's what today is about, sharing the data with the public. So this is just our 2022 results for Enterococci. And this analysis was done by Dr. Nicole Fahrenfeld, who is a researcher on Rutgers with the School of Engineering. And what these boxes are showing is each box shows a different site. And they're numbered. So this first square over here on the upper left is Riverside Park. This the second one is Rutgers Boathouse, then Edison, Ken Buchanan, South Amboy, and 2nd Street. And each black dot here represents one of our samples, one of our Enterococci samples. Okay, so the red line shows again that water quality standard that I was talking about before. Remember, it's 104 CFU. So it's above the red line. You can see that it was above the water quality standard. And if it's below the red line, you can see that it was below the water quality standard. And then you can look at each site this way, and you can see for each site what were the results. This is just for 2022. And then these blue bars here show precipitation. Okay, so on the left here, on the left side here is enterococci, and all the way on the right here is precipitation, 2-day antecedent precipitation. How much rain did we get 2 days prior to sampling? And what you can start to see is that there's a kind of a correlation here between precipitation and enterococci. So for example, just looking at Riverside Park, you can see here when there was no rain, for example, hopefully you can see my arrow here, hopefully. The dots are, the samples came up below the standard, and then when we got more rain, in general, it was above the standard. And when we do look at the statistics, we can see that the variation in Enterococcus data was statistically correlated with precipitation and also salinity. Okay, and there is a significant correlation there statistically. So that kind of makes sense, right? When we have a rain event, I can talk about this a little bit more. I think it's in the next slide. Here, we'll talk about this a little bit more. Unless Heather, did you want to take this slide, or did you want me to cover this?
Sure. I'm happy to talk about this, and then we'll sort of jump back and forth between.
Okay, go ahead.
So yeah, in terms of where the rubber hits the road and the interest of a watershed organization like the Lower Raritan Watershed Partnership, what is our interest in understanding how enterococci end up in our waters? So what we want to know is how we can make a difference. How can we work to clean up these waters? So in that, we need to know the cause. Human and animal fecal sources can enter, of course, from agricultural activities, far upstream. That's more in a rural or somewhat suburban landscape. But in our area, we're looking at stormwater runoff from hard surfaces. So we have a lot of what's called impervious cover throughout our central New Jersey Lower Raritan landscape. And with that hard surface, those asphalt driveways and parking lots and big warehouse rooftops, you get a lot of water, that precipitation that doesn't have any place to go. And as it washes off those hard surfaces, it takes all of the pollutants with it, and washing them off into our waterways. So we have the hard surfaces. We have broken sewer lines, failing infrastructure, old infrastructure, animal waste, household pets that the waste isn't cleaned up in the yard. We have also something called a combined sewer overflows. And that's most prevalent in our Perth Amboy site. And with combined sewers, what we have is basically old infrastructure where we have our sanitary sewage, where our toilet flushings go, our sanitary sewage waste infrastructure combines with the piping and the infrastructure that is created for our stormwater flows. And those are combined en route to two places. One, to a processing plant, for the sanitary sewage, but two, for where the stormwater runs out into our waterways. The image on the far right is of a CSO, or combined sewer overflow, where you have that old style combined sanitary and stormwater infrastructure mixing and flowing out into our waterway. Now, a combined sewer overflow isn't always a problem if it's not rainy. When it rains and you have displacement of sanitary sewage in a combined sewage pipe, that's when you get problems. So we need to think hard about retrofitting that infrastructure. We need to think about how to prioritize our other infrastructure, our broken sewer lines. We need to fix those in our communities. And we also need to talk about reducing the amount of impervious cover and hard surface so that we minimize the human and animal fecal waste that ends up in our streams and in our rivers. So, and as that slide says, if we know the source, we can address the problem.
Okay, I can cover the qPCR part of it.
Sure.
Yeah. Okay. So just a little bit deeper dive into this. We've established that the fact that there is some issues with pathogens at the Lower Raritan River. Now we want to know, well, where is it coming from? Where are these pathogens coming from? What's the source, right? So we've been working with Dr. Nicole Fahrenfeld's lab to try to get at where are the source, what are the sources of some of these pollutants, and they use a technique called qPCR, quantitative polymerase chain reaction, and it's a technology used for measuring DNA. So essentially, we want to understand where these fecal sources are coming from. Are they human? Are they livestock? Are they dog? Are they goose? So once we understand where the sources of these pollutants are coming from, we can do a better job figuring out how to reduce them and shut them down. So these pictures here kind of shows sort of the process. We are not really in the lab. It's really Dr. Fahrenfeld's undergraduate students and graduate students that are doing this work. This is Genevieve right here, who did a great tour for the community recently of the Fahrenfeld lab, showing the process for how these samples are processed. But essentially what they're looking for is, we're really looking to see if they're human sources. The samples are filtered and assessed for potential match for human fecal markers. Okay, so that's what this data is showing us here. We're looking for they're using qPCR to tell us whether or not the pollutants that we're seeing are as a result of human sources of pollutants. So this data is from 2020. It's a couple of years old now. And this is the results are looking from our first site in Piscataway, which is all the way upstream, to our more downstream sites. 5 and 6 are our more downstream sites. And in 2020, we took samples to the lab for them to do the qPCR analysis. Last year, EPA was doing a similar kind of analysis, again, to look at sources. And what they did find was that these orange triangles here are showing where this gene, it's called HF183, that's the human fecal marker. Those orange triangles indicate where there was potential sources of human pathogens in the water, human source of pathogens in the water. Okay, so they were seen at Piscataway, they were detected, and they were also detected at New Brunswick and at low levels in Edison. That was detected once in Perth Amboy. Okay, so this is all just evidence pointing towards a story. We're taking all these pieces of information to try to figure out where these sources of pollutants coming from. By the way, the black dots here are similar to the black dots on the other slide, and the red line is again that water quality standard. And for 2020, is just showing you for each site whether or not the samples that we took were above the water quality standard or below the water quality standard. Okay, so we're also, okay, so this is something else that what we were doing on the river is that we are using, Rutgers has a Raritan River Hydrologic Observatory where this data is being, the weekly results are being posted. So in one, I think it might be the next slide, I don't remember, there's a QR code that you can scan so that you can go right to the results. And this is a map of each one of our sites. Here's Riverside Park, here's Redgrid Boathouse, there's Edison Boat Basin, there's Sayreville, there's Perth Amboy, there's South Amboy, and you can click on each one of these sites, and you can look at a graph of the data, download the data if you'd like. And then also it comes up as a frowny face or a happy face, depending upon if there are low values or high values that week. So this is just for the week of October 6, 2022. This is the last week that we sampled in 22. When we start up sampling again in May, this will be updated every Friday. So you can go on and take a quick snapshot to see what the results were. Okay, there's the website on the bottom, tessera.rutgers.edu/RRHO. And then I think there's a QR code. On
I
one
think
of
it's
the
a couple slides
a
up.
couple of slides. Okay. And Heather, feel free to weigh in here, because I know that you're doing a lot of this work where there's ways that we can all keep pathogenic bacteria out of our waterways. One, by maintaining the sanitary sewer system that Heather was mentioning earlier. Maintaining that infrastructure is incredibly important, and making sure that there aren't any leaks that we don't know about that are potentially sources of these pathogens. Going through and evaluating stormwater outfalls that discharge directly to our local waterways. Most people do not realize that. Most people see those storm basins on the street and think that it goes to a treatment facility. They do not realize that it goes directly to our local rivers and streams. Implementing stormwater best management practices. Maybe you've heard of the term green infrastructure. Hopefully you have. Green infrastructure are things like rain gardens, permeable pavement, bioswales, all of these practices that can be used in our community that are mandated now by the stormwater rules. For any new development has to use green infrastructure to infiltrate stormwater on site, infiltrate rainwater on site, so that these practices can help filter the pollutants out of stormwater runoff. And then obviously supporting community stewardship, coming out and helping us, volunteering with your local community, volunteering with the local Lower Raritan Watershed Partnership. These are all ways that we can reduce pathogens from going into the waterway, picking up after your pet, not feeding the geese. All of these common sense practices are important. Okay, and then for you, for this, I'll turn it over to you, Heather.
Okay, so in terms of our fund plans for 2023, and we do have a lot of great plans for upcoming monitoring season. Actually, before I jump into this, can someone drop in the links for the Raritan Hydrologic Observatory?
Sure.
Yeah,
Yeah.
great, thanks. So we will continue our monitoring at our 6 non-bathing public access beach sites, and we'll continue reporting out in English and Spanish. We're going to ramp up our Spanish language outreach in particular for summer 2023. And again, I just want to, I don't know if we've emphasized the reasoning behind choosing the non-bathing public access beach sites. So our bathing beach sites are those sites that our county and state health departments regularly monitor, because they are required to monitor them, because they have sanctioned bathing or primary contact activities. So what we do is we monitor at those locations where the state and the county health departments are not involved. They are not doing active monitoring. So part of what we'll be doing this summer is continuing our sampling, continuing our reporting out, continuing our reporting out in English and Spanish, and also improving our understanding of who is actually using these sites. So that's part of our 2023 plans. How much primary activity is there at our water quality monitoring sites? We will be working with EPA. This will be our 3rd year of working with them on genetic analysis. We call this our source track down. So it's kind of the same thing that the Fahrenfeld lab is helping us with in terms of doing a tracing for the source, whether it's human or bird or dog or other animal source for the fecal matter, the fecal contaminants we're seeing in our waters. So we will continue with our third year with EPA. We're going to add in for 2023 a sampling for chlorophyll. Some of you may have heard of what's called HABs, or harmful algal blooms. And we are going to start trying to understand the potential impact of chlorophyll flows on the Raritan River. So we are going to be adding in sampling for harmful algal blooms. We are going to continue administering the survey, and we'll share a link to our survey in just a minute. And we're also going to keep pushing the link between our land use and land use policy decisions and our stormwater management concerns around water quality and water quantity. So how do our policies around where you can develop in our municipalities influence the water quality in our streams and our river? We're going to look more at maintenance of our outfalls. We're going to look more at how we can support our municipalities in putting in more green infrastructure, like rain gardens, rain barrels, cisterns, ways to keep the water out of the stream so that it's a slower trickle through into our waterways, so that the landscape is doing the job of sort of natural filtration of these stormwater flows, of the fecal laden waters before that runs into our streams. So, okay. Great. And we have Samantha on to talk about the big picture of how the work that we're doing in the Lower Raritan intersects with work taking place throughout the whole of the New York, New Jersey harbor estuary.
Hi, everyone. I'm Samantha Wilder. I'm the program coordinator for our Coordinated Volunteer Pathogen Monitoring Program here at the Interstate Environmental Commission. And the Lower Raritan Watershed Partnership is one of 8 groups that I work with during the summer for monitoring locations that aren't generally monitored by any regulatory agencies. So I basically provide training, and I go out with, I'll be there May 18th doing the training. And I work with the group weekly during the summer. I have someone to go pick up samples that are collected by Jocelyn and the rest of the team, and they bring it back to our lab in Brooklyn. And we just moved to our new location at the Brooklyn Army Terminal. And I'm the one who processes the samples, as well as my intern who will be returning this summer. And I distribute the results on Friday, as well as with all of my other groups. And I do about 22 sites each Wednesday and Thursday. I have one group that does Wednesday, and then Raritan is included with the other 7 that sample on Thursdays. And then even bigger picture, we are involved with the Billion Oyster Project and their community water quality testing program. And that is also involved in the New York, New Jersey harbor. They do a total of about 70 sites. So from the Enterococci and fecal coliform results that I get from Lower Raritan and other groups like Hackensack Riverkeeper, I submit the Enterococci results, and that is compiled onto a very large Google spreadsheet. And that's generally the bigger picture of what Raritan, the Lower Raritan Watershed Partnership is included. And that's it for us.
Great. Thank you. And Samantha is going to join us in the field on May 18th. I see questions about how to get more info to register for our May 18th training. I think Jocelyn will drop that in the chat box as well. And I just want to emphasize that the work that we are doing in partnership with IEC and EPA is done through quality controlled means. So basically we require that folks go through training to ensure that it meets the standards for EPA data review. So we want our data to be maximally usable primarily for folks in the Lower Raritan to make choices about their recreation on the water. But we also want our water quality data to be useful for decision making at local, state, and federal levels. So we want to have as stringent quality assurance controls on our data as possible, which is in part why a partnership with the IEC and with the EPA is so important. So we're enormously appreciative of Samantha and IEC for working with us on this. So I think the next person up here is Victor, who's going to talk about some of the preliminary results of a survey that we have been sharing out with community groups and individuals for the last year or so. And Victor, I'll just let you jump in now.
Hi, good afternoon. My name is Victor Aguilar, and I am a senior at Rutgers University, New Brunswick, majoring in environmental policy, institutions, and behavior, and minoring in sustainability. And I will be discussing the preliminary results of the survey, Public Perceptions of Pathogen Monitoring on the Raritan. Next slide. So the goal of the research in this survey was established by the Lower Raritan Watershed Partnership with Rutgers Cooperative Extension. By the way, it is accessible through this QR code in the upper right if any of you would like to take a moment now to scan the code and answer the survey if you haven't. The goal of this survey is to learn how people use the Raritan River and whether the water quality monitoring that has been happening for the past few years has impacted the perceptions on the river. And there are questions related to, some of the questions were actually brought up in the previous polls, if any of you have used the results of the water quality monitoring that the Lower Raritan Watershed performs, and there are questions related to what activities you do on the watershed, what you think their safety is, and how aware you are of the health of the river, followed by some demographic questions. So this survey, as of right now, is aiming for 400 respondents. Right now, we have approximately 150 responses. The survey takes 5 to 10 minutes to answer, and like I said, it asks questions on your usage of the data and your opinions on recreation. So right now, as I previously mentioned, I am an undergraduate student and I am doing my senior thesis on equity and accessibility in watersheds and their management. And as part of this research, I am doing a preliminary conclusions on this survey. And the goal of my conclusions is for the Lower Raritan Watershed Partnership to better understand resident needs and engagement through these conclusions and start to make considerations. So yeah, as I mentioned, the QR code is in the upper right here if any of you want to take a moment now to scan it. Okay, we'll be going to the next slide. So here I have some preliminary results from the survey. Hopefully this bar graph is visible enough. So based on these results, this bar graph actually depicts a question where people were asked to mention what activities they do in the river, but not counting their most performed activity. So based on these results, the most preferred and highest rated activities in the Lower Raritan watershed are walking, biking, and observing scenery, which are activities that do not involve primary or secondary contact or even any direct contact with the water. Boating and kayaking activities, which are activities that can be done above water, were not commonly practiced in the waters of the Raritan, but received average ratings of 2 to 4 stars out of 5 stars. The question asks the respondent to rate the activity, the safety of the activity from a scale of 1 star to 5 stars, 5 stars being the best and 1 star being the worst. And swimming and fishing, activities that involve underwater contact, were considered unpracticed and unsafe by the respondents and were getting low ratings of 1 and 2 stars out of 5. And there is also a fair amount of population responding to the survey that do not do any activities in the river. Based on these results, there's also partial awareness of water quality monitoring data of the partnership, but there is little usage of the data. There is also concern by the respondents of what affects the health of the water, but there isn't a complete familiarity on these subjects. And there is a lot of concern as well over over making contact with the water, and there are preferences to do activities that, as I mentioned, that are not directly contacted with the water. And we can also determine from the survey that the biggest response population is white residents or students in Middlesex County. And these results, as I mentioned, are depicted in this bar graph right here of activities that people perform in the waters of the Raritan. So some preliminary trends observed in this survey, these were divided into students and local residents. So it was majorly identified with students answering this survey that students were mostly unaware of water quality monitoring that the Lower Raritan Watershed Partnership performs. These students either do not do any activities on the Raritan River or do activities that do not involve direct contact with the water, such as walking, observing scenery, walking dogs. Students are mostly not familiar with processes that affect the river health. And at the end of the survey, there was a section where people could leave comments of whatever they desired. And the comments that most students left were related to wanting to get involved with the river and a wish for more recreation and health improvement in the river. It was also observable between local residents that local residents of the area were more aware of water quality monitoring, were more likely to do activities in the waters of the river. Yes, the link to the survey is right there in the chat if anyone would like to answer it. Residents were more likely to do activities in the water, such as boating, kayaking, swimming, were more familiar with the processes that affect river health. And most of the comments that they left in the survey were that they wish to swim in the river again like they used to do years before. And that, yeah, they want to be able to swim again and to the river to be unpolluted. And finally, I would like to mention that no trends were observed between demographic questions, which were related to race, county, age, and questions that didn't have to do with demographics. And by this I mean, for example, people who responded they were Hispanic or Latino had no observed trends between that and people who responded they're white, for example. So yeah, those are some trends observed with the survey. Yes, so thank you so much for your attention here. My email is right there in the presentation if you have any additional questions, and I will be opening the floor for questions now if there are any questions at the moment.
I think maybe we can open things up for questions about all aspects of the presentation, if that works for folks.
Yeah.
So we see a full class with Principal Clifford. I'd like to give the high school students a chance to ask any questions. I see a question here. Is fishing legal in the river? Yeah, so that's a great question. It is legal. Yes, it is legal to fish with permits, yeah, of course. Yeah, I think your question probably relates to the safety of the fish. There are advisories regarding consumption of the fish that might be caught in the river, in the Raritan River waters. And that's part of what our interest in water quality is related to, is the fishing for consumption piece of things. Fishing itself is legal with proper permits, but there's a lot of uncertainty regarding the safety of the fish once you have caught it for consumption to eat. There are other questions?
Bill Schultz has his hand raised.
Yep, I'm going to, Schultz, do you want to unmute?
And there's a second question. Do people eat the oysters or clean the water?
so high in Piscataway. Actually, two questions. One, how do you account for the drop off, the lower readings below Piscataway? Is the Enterococcus diluting, or what makes it go away? Second question, since Piscataway seems to have such high readings and it drops off below, is there any interest in monitoring above Piscataway, looking, maybe we can identify where the problem starts? If we've got clean readings somewheres, then stop going up from there. And, you know, we'll be able to isolate a little bit as to where to search for the problem.
Right. So I can start answering, and anyone else should jump in. So yeah, so what you Bill is pointing out, probably you saw on those graphs that you know, some of our sites were better than others, and in general, so the sites lower on the river had lower pathogen levels than our sites upstream, and Piscataway is especially, you know, has especially high levels. So the reason why that is probably our sites lower on the river are benefiting from that flushing, from that influx of water, you know, from the ocean, from marine waters coming in. And so there's this flushing that's kind of going on. Certainly that's what's going on in South Amboy, you know, where you have waves coming in. In terms of getting at the reason that Piscataway levels are so high, yes, we would like to do that, and every year we kind of come closer to that. EPA has been doing pretty intensive sampling there also, and we're looking forward to seeing those results. And then also we've been in some conversations with the DEP to look at, you know, potentially to try to get at what you're saying, Bill, with doing kind of like intensive sampling there upstream, even during, you know, storm events, before storm event, during storm event, to try to get at where this actually is coming from, getting in there with kayaks and canoes and like doing a really good sweep of the river there to look at dry weather, any dry weather flows that potentially are going on. I don't know if anybody has
I'll just jump in. I think what we've been doing over the past few years is really zeroing in. You know, we started with, you know, casting very wide net of concern over the Lower Raritan landscape. You know, we had identified sites of potential interest. You know, you have to start to gather data so you know where there might be need for further investigation. So that further investigation for us has included the genetic source track down in the last couple of years to try to see what we're dealing with in terms of fecal waste. You know, is this a human cause or is this an animal cause? You know, so each year we are refining our approach and adding more partners to help us zero in on where the problem areas are. You know, as Michelle said, EPA in particular is doing a study in the area above the Piscataway landscape. You know, so they have this year will be really looking at wet weather flows in the Bound Brook up and to Piscataway area. Yeah, so I hope that answered your question. Oh, I see. He's shaking his head. So, well, we can talk more about that. I do see some other questions. I want in particular to let Irene ask a question, and then also there was a question about oysters.
Right.
So, Irene, I've put you on unmute. If you want to unmute.
Unmute. Oh, is that better?
Yes,
we can hear you.
Can you hear? Okay. Yeah, I was wondering if signs about the quality of the water are posted at each of the places you do you're sampling, and perhaps a few other places where people either fish or do whatever they do in the water. Or at least if not the results are posted, at least a QR symbol is posted at these places. So
Oh.
people can use their cell phone to get the info. Because what I'm thinking is, if you rely on people to go, let's say to go to your website before they go out on a kayak or go fishing, that's something they have to do actively. And I don't know how many people would do it. If you have the results at the site, they're going to read it. It's much more passive if you're coming to them and rather than asking them to come to you. So I just wondered if it's posted other than on a website.
Irene, look for this image at your local waterway. So at our 6 sites this year, will be posting a sticker with a QR code that will take you to our data. So that's what this image it shows, is basically what to look for, so that you can get essentially real-time information about the water quality. It will this will share findings from every the Thursday sampling, Friday analysis. Let's though emphasize that if there are rainy or wet weather conditions, those are the times when you really should be mindful about maybe not taking risks around primary contact with the water. Those are the times when we see the contaminant flows, the pollutions, the pathogen pollutions, from the runoff. So anytime it's raining, you will absolutely want to think twice about your on-water activities, and you will absolutely want to wash up, much more thoroughly with hot water and soap, after your contact with the water.
Okay, thank you.
Yep.
By the way, it works. I just tried it.
Great.
Great. So regarding oysters, who does maybe Samantha can answer that question? Is she still on?
I'm still here.
Yeah. So since you do work closely with the Billion Oyster Project, do you want to talk a little bit about the oysters?
I might not be able to answer it very well. I don't work on that part. I'm more so water quality than on their oyster program, but they have a lot of information on their website about it.
So I'll just briefly, the Lower Raritan is not a source for oysters as much as Raritan Bay is. Okay. So in terms of people eating oysters from the Lower Raritan, that's not something that we encourage. That's not something we're aware of. We don't even really know where oyster beds on the lower main stem of the Raritan are. To your second part of the question, if I understand this right, is do people clean the water? Well, that's what we're talking about here, is how can we improve water quality by the land use choices we are making. Those land use choices are, where are we putting our infrastructure? Where are we building new buildings? How many trees are we planting along our streams? Are we building up the stream banks so that the natural plantings are doing the job of filtering the pollutions before they make it into our streams and in our waterways? So in terms of cleaning up the water, there are all sorts of decisions that we can support our municipalities to make around improving water quality, but they're not just like, it's not like cleaning up the water, like going out and filtering things out, although we do have many, many stream cleanups throughout the year. But really the big changes are going to come from the way we treat our stream buffers, the way we treat our land, and the way we work to retrofit our infrastructure, our sanitary sewage and our stormwater infrastructure. I think that that's probably all we have time for right now, but we would absolutely welcome the opportunity to continue the conversation with other classroom activities. We'd love to get folks out on the Rutgers research vessel. Will be hosting an online event on ship event in 2023. We'll take folks out on the water and show them how we use the tools that we do to monitor our water. And we welcome ongoing conversation about how we can improve our approach to delivering the data, so more people know about the data that we do have, so that they can make informed decisions about recreating on the waters.
All right.
So a huge thanks to all of you who joined us today, students and friends. Huge thanks to our presenters, to Samantha Wilder, to Victor Aguilar, to Jocelyn Palomino, Michelle Backus. There are several links in the chat box to our data, to our water quality monitoring trainings. I am thrilled to see Andrew turn on his camera. He's wearing LRWP shirt. Our volunteers who go out into the streams every week are happy to show off their stewardship. And you too, if you join us in the stream and get trained, you'll get a shirt just like that to come out and help us out. So. Yeah, so well, a huge thanks to everyone. Really appreciate it. And we hope to see you out in the water.
Bye, everybody. Have a great weekend.
Thanks.
Bye.
Thanks for joining, everyone.